Unit 10 is about right triangles, and before we even get into triangles, we need to know how to simplify radicals. If you've had me before in Algebra 2, we've done this, but it'll be a good review, and it'll definitely be for the ones who have not had me before. So what is a radical? A radical is this root symbol that is used to denote square roots or nth roots. So we can have square roots, we can have cube roots, we can really have any nth root that we want. But let's talk about a square. So what makes something a square is it has all four sides the same. So the first perfect square is actually 1. And then let's say I want to increase that. So if I make this now 2 squares, I would have to make it by 2 squares. And so then this would be 4, and the square root of 4 would be 2. So you're basically trying to figure out what are numbers that when you multiply them by themselves, they make that number. We're saying then the square root of 4 would mean what number times itself makes 4 is 2. And so these are actually on the top row of my back wall. So the next one would be having like a 3 by 3 square. And 3 times 3 would be 9. So the square root of 9 is 3. And then it'd be 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. I would go a little bit bigger than that. 11 times 11 is 121. 12 times 12 is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. Shouldn't need to go any higher than that. So what you're trying to do is you're trying to square root this number, meaning what number times itself makes 128. Well, looking at our list here, perfect squares, 128 is not on there. So what that means is I have to break this up. And so I've got to figure out what multiplies to make 128. And so you want to start on the top part of your list. I know obviously 225 is too big, can't be bigger than that number. 196, no. 144, no. 100, no. You could start trying like 128 divided by 81. If it's a decimal, then it's not a factor. You could try 64. And what you'll notice about 64 is if I doubled 6, that would be 12. And 4 times 2 is 8, so it takes 2 64s. So first I'll actually write like this. So this is true that 64 times 2 does make 128. And what's happening there is those are really just separate square roots getting multiplied. And so this is a perfect square. What number times itself makes 64? That's just a normal 8. And then I have times square root of 2. And so that would be the simplified answer. The way you could check is this is going to get a decimal. And I could do 8 square roots of 2. And that'll be the same decimal. So that shows that these are the same value. Okay, and my next one is 224. Let's say... well, I'll do it the right way first, and I'll show you what not to do. So 224, we want to see what that can be divided by. 81? No. 64 again? Nope. 49? Probably not. 36? No. 25? No. 16, yes. 16 times 14. So I'll have a square root of 16 times a square root of 14. This is the perfect square. 4 times itself makes 16, so this is 4 square roots of 14. Here's what not to do. Don't start on the bottom side of your list and try 4, because that also works. 4 times 56 makes 224. And the square root of, what did I put, 56, sorry. Square root of 4 is 2, square roots of 56. That is still the same value, but 56 has the perfect square of 4 in it again, 4 and 14. So you would have to go again, and then the square root of 4 is 2. You would have to multiply it by this 2. So you'd have 2 times 2 times square root of 14, or 4 times square root of 14. So this is definitely the longer process. Always start with the bigger side of your list and work down so you know you're getting the biggest perfect square taken out. Also, I want to mention too, you might get something as simple as square root of 81. since that is on our list, that is a perfect square of just regular 9. So sometimes those will show up as well.